Hello students, this video is the continuation of previous video, Basis of Classification Part 1. Here we discuss more basis of classification of multicellular animals. As you know, there are several fundamental features which are used as a basis for animal classification. In previous video, we discussed about level of organization, pattern of complexities in different organ systems, and now in this video we will discuss body symmetry, germ layer and body cavity. So let's start with body symmetry. On the basis of body symmetry, the animals can be divided into three groups. Number one is asymmetric animals, number two is radially symmetrical animals, and number three is bilaterally symmetrical animals. Here we start with asymmetric animals. When any plane passing through the center does not divide the body of organism into equal halves, the organism is said to be asymmetric. For example, sponges. Next is radially symmetric animals. When any plane passing through the central axis of the body divides the organism into two identical halves, it is called radial symmetry. Radial symmetry found in some sponges, coelentrates, ctenophores and adult echinoderms. As shown in a figure, there are several planes passing through the central axis of the body of the organism, divides the organism into identical halves. Next is bilateral symmetric animals. When the body can be divided into identical left and right halves in only one plane, it is called bilateral symmetry. Bilateral symmetry found in platyhelminths, asclepihelminths, annelids, arthropods, mollusks, hemichordates and chordates. You see in this picture, this plane divides the body of organism into two left and right identical halves. Next is germ layer. Depending upon the germ layers in the embryo, the animals can be diploblastic or triploblastic. First we discuss diploblastic animals. Those animals in which the developing embryo has only two germ layers. That means an external ectoderm and an internal endoderm are called diploblastic animals. Diploblast includes coelentrates and ctenophores. Next is triploblastic animals. Those animals in which developing embryo also has third germinal layer, that is mesoderm. Mesoderm is present between ectoderm and endoderm. So those animals in which mesoderm is present between ectoderm and endoderm is called triploblastic animals. For example, platyhelminths to chordates all are triploblastic animals. This is a figure of diploblast. This is ectoderm and this is endoderm. Mesoderm is not found here. Instead of mesoderm, there is a non-cellular, non-living layer is present between the ectoderm and endoderm. This is the figure of triploblast. Here, mesoderm is present between ectoderm and endoderm. Next is body cavity, or we can also say as coelom. Coelom is a liquid-filled space between the body wall and gut wall and is lined by mesoderm. Coelom contains most of the visceral organs. On the basis of nature of body cavity, animals are divided into following category. Number one is acoelomates. Animals without body cavity are called acoelomates. For example, platyhelminths. Second is pseudocoelomates. Body cavity is not lined by mesoderm and mesoderm present as a scattered pouch. That type of body cavity is called pseudocoelom. Pseudocoelom is present in asclepihelminths. Next is coelomate. Those animals which possess true body cavity are called coelomates. Their example includes annelids, arthropods and chordates. This is all about basis of classification. Thank you.